Okay. Alright guys, apologies for the interruption in between because of some technical issues. Our live stream got switched off, but now we will continue. Let us continue from where we left. This is going to be the part 2 of the live stream. So like yesterday I have created 2 parts, right? Part 1 and part 2 for session 6. Very similar to that, I will be creating the same thing for session 7 also. Today was session 7. Part 1 was already done before, it is of 7 minutes. Now we are into part 2 and I will be putting both the videos separately in one single playlist. Okay, let us continue from where we left. We actually left at this particular place where we were understanding the concept of arrays, how the array was working and what was the difference between array and the linked list. Okay, I explained you the features and things that array was having. The next thing that we are going to talk about is going to be linked list, and I will be explaining you about how this linked list works. Now all these issues, as I told you, are there with this array concept, so that's the reason why we have the concept of linked list available to us. Now in this case, in this linked list concept, what happens is that everything is just opposite of what you saw in this array. In this case, means in this case the array size was fixed. In this case the linked list size is not fixed. Size is not fixed means it is what? It is dynamic data structure. It is what? It is dynamic data structure. So linked list on the other hand is what? It is a dynamic data structure. This is our linked list concept. The size is not fixed in this case. That is the basic difference between this array and the linked list. I hope so that this is very much clear. Now let us understand the concept in a more depth way so that you will be able to understand the concept clearly. Let us talk about this. So in this case we are talking about linked list. So how does a linked list looks like? Now I am gonna explain you in depth. So see here, generally the linked list is created like this. We have a square node like this and there will be multiple nodes connected to each other like this in one line like this. Connected like this. Okay. Now in this case this is our first node, in this case this is our second node, this is third node, and that is fourth node. Now every node is actually divided into half. First of all, before I go ahead into this, if we talk about the types of linked list, then in this case there are many different types. You have singly linked list. What is this singly linked list? Remember, single direction, singly linked list. Then we have doubly means double direction. Okay, and in this case circular means it is like in a circle formation. We have ordered / unordered, and this variety of linked list comes actually into all these different parts. Right now today we are actually doing singly linked list. Okay, understood this? Let us continue. Okay, so now we are doing singly linked list. Okay, let me quickly explain you how this is working. All right. Alright, so every node here is divided into two partitions basically. The first partition says that this is the place where you store the data, and the second partition tells us that, second part of this partition tells us that this is the place where we store the address of the next coming node. Okay, this node, this partition stores the address of another node. Understood? While this partition stores the address of the next coming node. I hope so that this is really understood by everyone. Okay, and this is the place where we store the data. I said 10, I said 20, I said 30, I said 40, and so on. Okay, very similar to that, in this case, very similar to that, this place will hold the address for the next upcoming node, which is this. I hope so that this color grading will make you understand how this is working. This part is storing the address of another node, this part is storing the address of the next node, this part is storing the address of the next node. Understood? Up next, we have to understand this, that this is our first node. How it is proved that that is the first node? There will be a pointer which is gonna be pointing towards the first node, and that pointer will be called as head pointer. Okay, head pointer. If I am saying that it is storing the address of the first node, okay, this will be address of the first node, that means it is gonna be a pointer, okay. Well guys, imagine this, because I told you that this is the place which stores the address of this, this is the place where it stores the address of this, this is the place which stores the address of this. That means these are also the places where we will store the next as a pointer. Understood? This also has next pointer. Well, similarly, this is also as next pointer. I hope so that this is understood. At last, in this case also, we are holding the next as a pointer. This is the explanation ray diagram of a linked list. I hope so that you have got my point. I believe, right? And everywhere this is gonna be looking like this. Now, also don't forget this, that every node here, every node has its own memory allocated. That means this node has its own memory. Similarly, this also has its own memory. Similarly, this also has its own memory. Similarly, this also has its own memory. I hope so that this is very much clear. Okay, this is the explanation diagram for the linked list. Now, I am going to explain you with the help of a proper example, where I am going to note down each and everything, starting with the very first node. This is, let's say this is the first node, and this is also partitioned into two parts because we are talking about singly. Now, in this case, this is our data here, okay, data here. Very similar to that, we have another node here which is partitioned into two parts, and we have the address, the next data here. Now, very similar to that, I have this node also where we have the data stored, and this is the next pointer. Very similar to that, but let's create one more node, and here I am storing the data 40, and that is how this is gonna look like. Let me make this node a little bit bigger node so that it is clear. Okay. Alright. Now, I told you that every single node will have its own memory allocated. That means this whole node itself, now listen to this very carefully guys, like I told that this node has its own memory allocated, meaning that this node or each and every node in this case will have its own memory address also. Unlike an array is one single large block of memory partitioned into many different parts, so its size is fixed. But in linked list, as I told you, the size is never fixed. It is a dynamic data structure. How? Because every node or the data has its own memory allocated in the linked list. Hence, there is no limitation of storing the number of data into a linked list. You can go till n number of nodes to be stored inside a linked list. That is the reason why it is a dynamic data structure. So, if I am saying that each and every single node that you see here has its own memory allocated, then that means each and every node will have its own memory address also. And you know how the address looks like. In the pointers class in session 2, I have explained this very well, that a pointer will hold the address of another variable, or in this case the pointer will hold the address in a hexadecimal value into it. We have printed it and also understood this. So, let us say the address of this node is maybe 0x64FEBC. Now, this is what? It is a hexadecimal value. Let us say the address of this node is 0x63FEBD. Understood what I am trying to say? But this, so like this, each and every node has its own memory allocated. So, each and every node will have its own memory address. But the point is, my point is that in this case now, what happens is that, I am not going to store the numbers or I am not going to store the memory addresses as a hexadecimal value inside my program, because otherwise you will get confused. So, let us make it more easy to understand. In this case, what I will do is, I will take some random numbers. I will say 2187. For example, I have taken 2187. This is the address of this particular whole node. Okay. Then I said this is 2872, maybe random number I am taking, okay, which is the address of this node. Then I am saying that this is your 2778. This is the address of this node. Then I am saying that this is, let us say 2877. Okay, none of the numbers are matching. 2877, 2187, 2872. Right. So, in this case, each and every number that you see here, let us take an example that these are the addresses of the each and every single node here. Okay. So, in this case, this is how it looks like. Right now, they are not connected. So, we will make it connected. And how we will make it connected? I will say, what was this? This was the data, 10, 20, 30, 40. This is the data. In the next pointer, what will be holding the next? This is a what? But this is a pointer. So, in this pointer, I will be storing this number 2872. I stored this value here. That means this node knows that it is connected to this node. This node knows that this is connected to this node. Next up, this node knows that it is connected to this node. How? Because 2778 is stored right here. So, 2778 is stored right here. So, this node is connected to this node. Okay. And they are connected in this direction. Okay. Then, what this will be holding? This is what? It's a next pointer again. So, this pointer is holding the address of the next node. So, in this case, this is the address. So, I am storing that 2877. That means this node knows that it is connected to this node. And do we have any other node next? No, we don't have. So, in the next pointer, here we will store null, meaning there is no node connected to this last node, which means it is the tail node or the final ending last node of this linked list. Hope you have understood this. If you have any doubts, please ask me in the comment section. Next up, This is how your linked list is looking like. But how do you know that this is your first node? This is their first node. Maybe it can be this first node. It can be this also as a first node. How do you know? As I told you in the example diagram that a head pointer is connected to this first pointing node, right? So in this case, there will be a head pointer. I'm going to make it nicely. This is going to be the head pointer. Head PTR. Okay. This pointer head will be pointing towards the head node, which means this node, which means this will store 2187 pointing to the first node, and hence this becomes your linked list. This is actually how your linked list will look like. I hope so that everyone understood and got this. All right. Easy to understand, right? Next. Now you see the difference. As I explained you, in the array, if you want to do some addition or doing anything in the operation, you have to write extra codes, and loss of data can happen in that case. But in this case, nothing happens like that. For example, if I want to add, right now my data is what? 10, 20, 30 and 40, right? And now let us say someone says that you said I want to add 50 in between 20 and 30. How will I do it? Understand this. How will I do this? Understand this. I will first take 50 as a node. I took 50 as a node. I created 50 as a node. Okay. And I said that its next is right now null because it is a newly created node. So in this case, what happens is that I want to insert this in between 20 and 30. So what I do? I break this link. I break this link and I said that this address 2778 is stored here. So this is connected to here. And I said that instead of this, you store the address of this newly created node. So which is n in this case. So this connection is made. So rather than you deleting anything or shifting anything, you just rewired the connections, and what happens? Nothing gets deleted. You just have to write one particular function for it and your job is actually done. That is the reason why linked list is so flexible, and we use this more than array in some particular cases. It is much more flexible, it is dynamic, and that is the reason why we use it. Now this is your linked list concept. I hope so that this is very much understood. In real life, linked lists are used every day in your life, and the example I am not giving you the actual example for linked list in real life, but now you listen. Actually, every day you are using a linked list, but you don't realize it. Now for example, in Spotify, you know Spotify, I am taking Spotify example from that session 1, right? Let's say you are onto Spotify and you want to change the music. How do you change the music? There is this next button, pause and play button, right? Then you have previous button, right? Like this in between. Okay. This process of you changing the song with these two buttons right here is what? It's a doubly linked list. This is what it is. This process is a doubly linked list. Okay. Doubly. It's a linked list. Your mobile phone gallery. Let me explain you this. In your mobile phone gallery is a linked list. When you open a photo, it opens up like this, then you swipe right or you swipe left. Okay. In that case, that's a good example of linked list in this case. Then take another example. You have Google Chrome. In Google Chrome, you have that back and forward button, right, to navigate between the pages. That's a freaking linked list. That is where you are using linked list. Then radio is a good example of linked list, where it is just a singly linked list because you can go into front of the music but you cannot come back. A good example is internet radios. Internet radios. Very few people might be knowing about this, but internet FMs will allow you to actually go and change the next song, but you can't come back to the particular song. Well, these are the places where we are actually using linked list in real life. I hope so that this message is clear to you, that linked lists are very easy to use and this is what they actually does. Now let us understand what exactly our how exactly we will be able to do this main other operations and what we can do with this, so that we can proceed into our concept today. Okay, understood what I'm said? Now when you this is the concept of linked list, but first of all what you need to learn in this, you need to learn how to implement this. If you know how to implement this, it will become very easy for you to understand the code and then write according to however the question is being asked. So in that case, understand how this linked list can be implemented. What all operations can be performed on this? If I talk about operations in that case, then in a linked list you can perform 3 major set of operations by default. In default, that is first insertion. Second one is deletion. Okay, insertion, then deletion, and then third one is gonna be traversal. Traversal can be done. These are the three common things that can be done. Let us talk about all of them one by one. Today let us start with the insertion. Okay, but before that, one more thing. In insertion you can also perform into 3 ways. And what are those 3 ways? Insert at head you can do, insert at a particular position you can do, and at last you can do insert at tail. Okay, in this case for deletion also same thing happens. Delete at head, delete at tail, delete at position, all those things you can do. Traversal is just one single thing that is gonna happen every single time when you do it. In this case we will talk about these 3 things. Let us today start with our insertion concept and understand how you can do the insertion. But before that, before even I go to insertion, let's move on to coding part and understand how this thing will work. Okay, let's move on to the coding part and understand how this is working. All right. Okay guys, so in this case this is the code, but let's write it from the beginning here so that this is better understood in this case. Okay, let us start with the coding part guys and understand how the linked list concept works. Okay, now you think about it, how you can implement this linked list. You see in this case you have this as a linked list, correct? You have this as a linked list, correct? This is your linked list. Now if I ask you how you would implement this, I can say that there are many different nodes, right? Many different nodes. So in this case what I will use? I will use object oriented programming. I will use pointers, and trust me guys, it will be very easy to understand. Okay, let's move on to the code first and understand the reality, how you will be able to do it. Let's start. I'll of course start with hash include IO stream, and I'll say using namespace std. Okay, and I'll set int main return 0. Okay, this is our basic code where we will be writing each and everything. I hope so this is very much clear. I'll just make the text a little bit bigger. In this case font size I'll increase. Okay, right. Next up I'll say, in this case I'll start by creating a class. Now guys, there will be 2 methods. Listen to this very carefully. There can be 2 methods. You see, first thing first, we need to create a class. No matter what happens, You have to create a class. How do we create a class? You start by creating a class called as node. Okay, because you see, I want to create a linked list, right? And linked list is what? It's a list of nodes. It is what? It is list of nodes. Well, in this case, imagine this. You remember the car example which I have given you in the very beginning of object oriented programming. You see, just imagine this. Just imagine this. Just imagine this, that there are these nodes. Okay. Now, I told you that there is no fixed size of a linked list. That means that can be n number of nodes, there can be hundreds and thousands of nodes. And if one node is taking, you only think yourself, if one node is taking 5 lines, example, if one node is taking 5 lines, then how many 1000 nodes will take? 1000 nodes will take 5000 lines. Correct? 5000 lines. But are you sitting here to write all the 5000 lines on yourself? No. Practically it is impossible. Every time we cannot do that. So for that reason, what we need to do? We need to use object oriented programming. We need to do object oriented programming. I hope so that this is very, very much clear. Alright. So let's understand how this works. Okay. So I created a class node. Why I created the node class? Because I can see that here in this case node are many, and if I want to create one node, I will just create a blueprint of that node. So hence we started by creating the class as a node in this case. Let us move on and understand. So I created a class node, and inside this class, C++ ends with a semicolon for the class, and in this case class node. Inside this node class, what will be the attributes of this node? Of course it will be int data, of course data, because we saw a node contains data, a node contains the data, and node contains the next. Correct? So in this case, what I'll do is I'll write data and I'll say node star next. Guys, be careful. This is what? It is a pointer. Understand now. If you have understood what is pointer and how it is working here, half of your jobs are done. Trust the process, trust me, this is gonna be very easy. Do not think that I have written a pointer so it has become very difficult. No. Trust me, pointers, if you have understood really well, you will be able to understand this concept so well that you start loving it. All the problems in DSA, then later on you will solve it using pointers. How? Understand this. In the example diagram, I had already explained you that we are storing the address of another node into the next of that current node. Yes or no? Yes. So in this case, what happens is that a node will contain two things, because there are two partitions. One is the data partition and another is the next pointer partition. So this is that next pointer where it is coming from. Apart from that, why I have written a node? Now if you understand this, guys, in our session 2, what I am trying to say is, in our session 2, where I have taught pointers, I told you the categories of pointers, remember? There I have told you there are two categories. One is typed and another one is untyped. Typed are your int star, float star. Now I'll write it like here. You had you remember I have written this. Int type of pointer will point towards integer value. A float type of pointer will point towards a float type of value. If you recall that, what I am trying to say, I am not going to teach you pointers again, but Understand this. Similarly, I have written structure type of pointer will point towards a structure variable. At last, if you remember, I have written this, that a class type of pointer. Let me explain you this here. Okay. Let me explain you this here, that in the last I have written this, that a class type of pointer will point towards the class object, isn't it? Isn't it? I have explained you this in session 2, right? That a class type of pointer will point towards a class object. What is happening here? This is what? Node. This is what? Node. Node is what? It is a class. And what is this? Class type of pointer. Correct? This pointer will point towards what? Again I am writing this. Int data you understood. Well, this is the node. Data is 10. What is this? Next pointer. Next pointer, correct? Where it is pointing? To the next upcoming node. Understand this, guys, very important, very important. This is your first node, this is your second node. Okay. Now, first node data is 10, second node data is 20. But I said this next pointer will point towards where? The upcoming second node. Understood this? So, if you start from the beginning here, first you will create this first node, and when you created this first node, you will create a class node, and here in this case it is divided into two parts. One is the data, this is that data, okay, and what is this? Node star next, it is this pointer, okay. What is this? This pointer is actually this. Understood? Why it is having the node type of data type? Guys, understand this. Why it is having node type of pointer? Why? Because where it is pointing now, very important, guys. Where it is pointing? It is pointing towards the whole upcoming node, right? It is pointing towards the whole upcoming node, right? And how that node is created? How that node is created? This node is created using the same class node. Am I correct? Am I correct? This pointer points to the next node. Next node is also created with the same class node. I hope so that this is very much clear. So, in this case, the data type of this next pointer will be node, which is the same class name. Star means it is a pointer, and hence it is next. I hope so that this is very much understood by everyone in the session, guys. Correct? If you have any doubts, please ask me. 6 viewers are seeing right now, and nobody is asking any doubts. What is happening, guys? Everyone understood everything? If it is that, very good. Yes, very good. Next up. That is why I have written int data and node star next. This is clear. What we will do next? What is the next step? Creating a constructor of the class. So, I will start by creating the constructor. How will I create the constructor? I will say if the node class is node, then the constructor name will be also node in this case. What parameter do it has? It will have int data as the parameter. I hope so that this is very much clear. Now, you may say, sir, why didn't you write the next pointer also? Why you have not written this next pointer also? Next pointer also. Why I have not written is because, do you know the address of the next upcoming node which is not even created? Listen to this very carefully. Do you know the address of the next upcoming node which is not even yet created? No, right? Ultimately, what is happening? if you want to create a node, you will go to the main and you may say right now that node star, I'll directly say if I want to create the object of this node, I will have to say node n, and in the constructor I can just pass the data 10. But do you know the address also of the next upcoming node in the future? No, we don't know. See, this is the constructor call, guys. And if you write this next over here like this, if I write this like this, then what happens? You have to give the address also while creating the object of the node class. Do you know the address of the next upcoming node which is not even created yet? No, right? That is why I will not write this node star next. I will not write this. I hope so that this is very much clear till now. Okay. So I will only write int data. Alright. Next, in this case, what we will write in the body, you know, everyone knows this dot. Now in C++ we don't use dot, we use arrow. We say data equals data. Everyone understood this? This arrow data equals to data. In Java you will say this dot data equals to data. Very similar to how Java is done. I hope so that this is very much clear. Okay. Now you have a next pointer also, no? Now guys, if you understand, I have taught you 5 types of pointers. What were those? Number 1, wild pointer. Number 2, null pointer. Number 3, dangling pointer. Number 4, double pointer. Number 5, void pointers. Correct? So there are 5 types of pointers which I have taught you. What are these 2 types of pointers? Can anybody tell me? What are these 2 types of pointers? They are wild pointers, right? Because they are not yet initialized. Correct? So it will contain a garbage value. From the storage class we have understood this, that those variables which doesn't have any which has auto as a storage class. If you see the storage class of these 2, it is auto. Storage class is auto. So what will be its default value? Garbage. Means these pointers can point towards some garbage values. I don't want that to happen. That is why they are called as wild. I have explained this in the pointers concept in session 2. Okay. So what we need to do? We need to neutralize them. We should not have a wild pointer in our program generally. So how will I neutralize? By making them as a null pointer, and hence I will have to write this dot next equals null. In C++ you will say nullptr in all small. I hope so that this is very much clear to everyone. I hope so that this is very much clear till now. Okay. This is gonna be your node class. I hope so that this is very much clear to every single one of you. Any doubts? Please ask me in the comment section. Well, nobody is asking any questions. I hope so that everyone has understood. Well guys, this is how you will start by creating the node class. Understood? I hope so that this is understood very much. Next up, we will continue in our next class. Why so? Okay, sir, can you please implement this in Java or C#? Okay, in Java or C#. Okay, let's do one thing. We can do this in a separate Java class, where we will, because if I do it in Java right now, what happens is that there are no pointers in there. So in a different style, you need to understand how the classes are implemented. All those things can be done, but I will give you the code in the description below, or I will reply to you in the same comment in the comment section below, okay, about how to write the code in Java. But for Java we will have a specific separate class on this. Okay, so at that time we can understand and explain on this. We are not doing that in C# right now, so not in C#, but we can, yes, do implementation in Java, but in later class. Any other thing? that you want to ask, I'll give the code of this same thing of Java into the comment section. I'll pin up the comment for the Java code. Okay. Apart from that, we will have a separate Java session on DSA for linked list. If you want, we can do that. I'll create a separate thing. Tomorrow, of course, tomorrow we are going to come live on Java as well. So we will explain you that there tomorrow in tomorrow's class, maybe. Okay. But that's all for today's class, guys, because already the time is over. Every day we are here for only 1 hour. I'm not going to continue more here because this first part of the linked list is over as of now. Today we have done an explanation, we have understood the concept, everything is clear, crystal clear here. If you have any doubts regarding this linked list concept or logic, please ask me. Apart from that, we have started the coding for this. We have designed the node class yet. Okay. In tomorrow's class, as soon as I will start the class, I will explain you there are 2 ways that you can implement the concept into using a different class and without using a class also in linked list. Okay. Where we will be using call by value, call by reference, double pointers, everything I will be using in the next class. Okay. So tomorrow's class, please do not miss tomorrow's class. Tomorrow I am going to come same 6 p.m. live on Saturday. Today was Friday, tomorrow is Saturday. Saturday 6 p.m. live, I will be there continuing this topic, and we will directly start from the coding for this concept. So do not miss that, very very important. And I will be doing the rest of the part as I told you. After this part, there are 2 ways we can do this in our linked list into. So that we will discuss tomorrow. That's all for today's live. And can you do more questions on this topic? Yeah. We will do it. First, let us understand and continue the concept. Okay. We'll finish up the concept and then I'll bring up some problems and I'll explain you there and there only. I hope so that this is very very much clear to all of you. Also, can you please cover interview question? Yes, we will only cover interview questions. Don't worry, we will not cover any random question. We will cover only company specific interview question. When I'll start a question, I will explain you in which company, in which year this question was asked, and then I will explain you. Okay. We will only do company specific questions only, because this series is not a random series, this is placement oriented series. And also guys, one more thing, before I go, we are also helping to provide placements. As we are providing placement assistance, we will take you to different companies, we will allow you to sit there, we will make you sit in the interviews, and then on your own you have to clear that. We will provide our 100% placement assistance also from Coders Arcade. We have also started that. So if you are interested in getting placements from our sites, please do contact us, and there are many different companies that are getting connected with us for this placements. So we will be providing placements as well. So if you want to get placed, contact us as well. Okay. And yeah, that's all for this session, guys. I'll be again coming in tomorrow's class and I'll be continuing the coding part of this. Okay. Do not miss that. Tomorrow is a very important day for the linked list concept. We'll continue in the next class. Thank you so much. Anybody any doubts? I'm here for 2 more minutes so that I can see the doubts and then I'll be leaving. Till now everything is understood? Right. Stay tuned. Yes, and don't forget to like, share and subscribe to our channel. Share this video to your friends, those who are seeking placements, and don't forget to like and share as well, like and comment also. Okay. Don't forget to press the bell icon also, so that tomorrow's next live session you'll get to know before that is aired. Understood? That's all. I'll see you guys in tomorrow's class. I hope so. That's all for today's class, guys. Thank you so much. Take care. and have a nice day. This is Ashank.